this is a video to go through the equilibrium questions. Hope you find it useful. Please mark them and make sure you understand all the mark scheme and the answers. So the question asks you to explain or to just state which type of bond joins the atoms of hydrogen. So here you've got your one hydrogen bonded to another hydrogen. Is it covalent? Is it metallic? Is it ionic? Well, it's fairly easy to understand because if you look at the periodic table, hydrogen is a non-metal. So hydrogen bonded to another hydrogen is a non-metal bonded to another non-metal. Also, you can notice from the picture that you have shared pair of electrons. This is the definition of a covalent bond. If they share a pair of electrons, one's a non-metal, the other's a non-metal, it must be covalent. It's not ionic because I've not made any ions. I've got no positive charges or negative charges. And it's not metallic because, well, hydrogen's just not metals. The next question, a catalyst is used in the reaction. Draw a ring around the correct answer. A catalyst increases the rate of reaction, increases the temperature, or increases the yield. Well, a catalyst increases the rate of reaction, and it is not used up. Okay? It does this by creating an alternative pathway for the reaction which has a lower activation energy. That's what a catalyst does. Last question, what is meant by the symbol here? Well, this just shows that the reaction is reversible. Next. So the question says, lowering the pressure reduces the rate of the reaction. Explain why in terms of particles. Now, I nearly made a mistake here because it's talking about the rate of reaction. It's not talking about the yield. Okay? So if you lower the pressure, why does the reaction happen slower? Well, the molecules will be further apart at lower pressure. Therefore, if they're further apart, there will be fewer collisions per unit time. Basically, when things need to react, they need to collide. So if you're trying to get the CH4 and the water to collide, well, the two molecules, to react, the two molecules need to collide. If there's less pressure, well, then there's less molecules in that space, so they're not going to collide as frequently. It's another way of saying it. The frequency of collisions is lower. Next, the graph shows the yield of hydrogen at different temperatures. So hydrogen is one of the products, okay? So it forms hydrogen. Now the forward reaction is endothermic. So it's endothermic forming hydrogen. How does the graph show that the forward reaction is endothermic? Well, at 250 degrees, the yield's about 51%, okay? So if you increase the temperature, increase T, the percentage yield of hydrogen also increases. Now, this is always the case in an endothermic reaction. If it's endothermic and you make it hotter, you put more heat into it, you get a greater yield of your product. Finally, why is there a higher yield product? Again, we're talking about yield product if it's at lower pressure. Well, looking at the reaction, you've got CH4, you've got H2O, and it forms carbon monoxide and 3 hydrogen. Now, on the left-hand side, you've got 2 molecules. You've got 1 methane molecule and 1 hydrogen molecule on the left-hand side. On the right, you've got 1 carbon monoxide and 3 hydrogens. So on the right, you've got 4 molecules. This is a 1 marker, so that's enough to explain why if you reduce the pressure, you would get less product. Basically, if you reduce the pressure, okay, on this, the equilibrium will move in this direction and will form more of your reactants and less products. These are really some of my favourite questions because it gives you most of the things you need to use in the question. Let's just make sure we understand the question. You'll be assessed on good English and making sure you organise it. In my answer, I'm not going to organise it or do the best English. I'll just give you the key points and the specialist terms. Table compares the two. If you don't use evidence from the table in this question, you will not get the full 6 marks. So you've got to make sure you refer to the evidence in the table. So let's start off with the advantages. Advantages of using hydrogen. Well, one thing is it forms water. You can see that from the table. So the product of combustion is H2O. Okay? Whereas the product of burning petrol, so I'll do in blue the advantages over. So the product of combustion of petrol is carbon dioxide and water. So the carbon dioxide, the problem with that is it is a greenhouse gas. And the problem with that is it contributes towards global warming. One of the next pieces of evidence we can use is hydrogen is produced from coal, natural gas or oil, but it can also be produced by electrolysis of water. Okay? However, we get petrol from the fractional distillation of crude oil. So an advantage of hydrogen is we can get it from water by electrolysis, whereas petrol, it is a non-renewable because it comes from crude oil. So now we're going to go to the disadvantages of hydrogen and the benefits of petrol. So we're going back to evidence again from the piece of information you've been given, that hydrogen produces less energy per litre. Okay. Another downside is that it can be produced, hydrogen can be produced from non-renewables. Now, if you explain that well enough using specialist terms, that should get you most of the marks. However, some really other interesting points are that when you burn petrol, you need a lot more oxygen, okay? So if you don't quite get that much oxygen, it won't burn completely. It won't do complete combustion as shown here. Instead, it would do incomplete combustion. An incomplete combustion can form carbon and carbon monoxide. Carbon monoxide, a dangerous gas, and carbon can form, the cause is, or what it can do is carbon get into the atmosphere and cause global dimming. So I've made lots of notes on the ideas. Now it says use the information in the table and your knowledge. If you only use the table, then you're not going to get full marks. If you only use your knowledge, you're not going to get full marks. You need to evaluate, so both sides. You should describe the advantages and disadvantages of using hydrogen instead of petrol. So you've been through both sides. It's worth 6 marks. You need specialist terms. Hopefully you've included most of those key points. So here what happens is you have both ethanol and water. The reason you have both of them is because they both can condense around the same point. So the water vapour and the ethanol both condense around the same point. Now, this is where the harder question comes. So the forward reaction is exothermic. So going in that direction, it's exothermic to produce this product. Use Le Chatelier's principle to predict the effect of increasing the temperature on the amount of ethanol produced. So this is the yield. Okay, so if I increase the temperature, increase T, how will this affect the equilibrium, and how will it affect how much the yield of this that I make? So if the reaction is exothermic, we can think of that as that it's giving out heat. So the two products are actually the ethanol being made and heat is being made. And what you're now doing is you're increasing the temperature by putting even more heat into it. Okay, so what's going to happen is the equilibrium will shift left to remove the extra heat. So the equilibrium will go that direction to remove the heat that you've just put in. So if the equilibrium moves left, okay, then actually it will produce less of my product of ethanol. Okay, if the equilibrium were to move right, it would make more ethanol. Next question. Explain how increasing the pressure will affect the amount of ethanol. So again, increasing the pressure, how does that affect the yield of this? Well, again, all you have to do is count up the number of molecules on the left. So actually, I have got 2 molecules on the left-hand side because I've got an ethene and a water. And on the right-hand side, I've only got 1 lot of ethanol. So I've got 1 molecule on the right-hand side. So if I increase the pressure, what I'm doing is I'm increasing the pressure on this side because there's already more molecules on this side. So to reduce that, the equilibrium will move right. If I've got 2 here and I try and increase the pressure, it's going to make it much worse on this side, on the left, which is why the equilibrium moves in that direction. So the equilibrium will move right. And if the equilibrium moves right, it will produce more ethanol. Last few questions. Reversible reactions can reach equilibrium in a closed system. What is meant by a closed system? So this means nothing can enter or nothing can leave. So you've just got a system where you've only got your products and reactants. Your products don't leave, you don't add more reactants. Next, explain why when a reversible reaction reaches equilibrium, the reaction appears to have stopped. Well, if it's at equilibrium, what this actually means is the forward rate, so the rate producing ethanol, is exactly the same as the backwards rate. So this is the rate where it's producing ethene and water. So if it's at equilibrium, both rates, forward and backwards, are equal. If they are equal, there is no change in the amount of reactants or products. However, the reaction is still going on because they're both changing into each other. They're just changing into each other at the same rate. Natural resource from where you get hydrogen. Well, the main one you get hydrogen from is methane, but you can also get it from water by electrolysis, so one of those two. How does a catalyst speed up the reaction? Well, it gives an alternative pathway, and this alternative pathway has a lower activation energy required. Looking at the next question, again it's quite similar to the ones we've had before. What happens to the amount of ammonia? So what happens to the yield of ammonia at equilibrium if the pressure is increased? So I've got on the left hand side, I've got 1 nitrogen and 3 hydrogen. So on the left hand side, I have got 4 molecules. On the right hand side, I have only got 2 molecules, so I've got 2 ammonias. So if I try to increase the pressure, it's going to affect the left hand side more, so the equilibrium will move to reduce the pressure. So the equilibrium will move that direction, it will move right, and if it moves right, it will produce more ammonia, or NH3. Next up, you're looking at the decomposition of hydrogen iodide into hydrogen iodine. It's reversible, I can see that there. The forward reaction is endo, okay? So that's endothermic in that direction. It's shown by the energy diagram drawn out to show the activation energy. Well, the activation energy, by definition, is the minimum amount of energy required for a reaction. So for this reaction to occur, what I need to do is I've got hydrogen and iodine bonded together. It's a covalent bond. The first thing I have to do is break that bond, so I need to put energy in. So the activation energy is me putting this energy in from here all the way up. This is the amount of energy I'm putting in to break the hydrogen and iodine so this reaction can be successful. So that is my activation energy, which I'm going to label EA. How does the diagram show that the reaction is endothermic? Well, this activation energy here to here is all the energy that I've had to put in. Whereas here to here is the energy that's being given out. So, is more energy being given in or out? Well, it shows that more energy is taken in than given out. And that's what endothermic means, more energy is being taken in. Another way to say what's happened is that the energy of the products is higher than the energy of the reactants. Finally, last question. We've kind of had this one again before. Suggest what effect increasing the temperature will have on the amount of hydrogen iodine. So the amount is talking about the yield. So if I increase the temperature, well, it's endothermic, which means more heat is actually going in at the start. Okay? So if I try and put even more heat in, what's going to happen is the equilibrium is going to move to reduce the heat. So the equilibrium will move right, okay, because if I've already got more heat on the left hand side, so if I put more heat in, the equilibrium is going to have to shift that direction. So what effect will this have on the amount of hydrogen iodide? Well, if the equilibrium moves right, less hydrogen iodide will be produced. That's all, thank you. Please make sure you've gone through it, ticked, corrected and added extra detail to your paper so you can learn from it. Thanks.